Most people diagnose EVAP systems like they do most check engine lights. If it's got a code, replace the part that set the code and hope for the best. In this video, I'm going to show you how I diagnose EVAP systems using one wiring diagram and one scan tool test function. So by the end of this video, you should understand what the computer, what the PCM is looking for with the EVAP system, and then how to use that information to find the actual fault in the evaporative emission system. So let's jump in and take a look. I'm Bill, and this is Bill Teaches Automotive Technology. Okay, so I've already done a couple of videos on EVAP systems. I've got one video on how EVAP systems work, all the different components involved in it. I want this video to be about diagnosing and helping you understand how they work. So just let's forget about codes for a minute. Forget about the parts that are involved because I covered those in the other videos. And let's look at what the PCM is actually trying to accomplish with the evaporative emission system. Okay, so I'm going to switch to the wiring diagram. There we go. And this is on a 2007 Chevrolet Impala to be exact. And let's look at the main components. We've got the fuel tank pressure sensor up here. We've got the vent solenoid right here. And then we have the purge solenoid right here. Those are the three main electrical components in an evaporative emission system. Once you understand these three components and what they do in an EVAP system, then the evaporative emission system becomes a lot easier to understand. Let's see what the PCM does with each of these components. Erase my annotations here. All right, so federal law mandates that fuel vapors not be released into the atmosphere. That's why we have evaporative emission systems. So how the PCM tests the EVAP system to make sure it's working is it's going to close the vent solenoid, okay? And you can see this is just a 2-wire solenoid. So it's either turned on or turned off. So what it's going to do, it's going to turn on the vent solenoid to close it. So that's going to be sealed, okay? Then what it's going to do, it's going to open the purge valve a certain percentage. So this is pulse width modulated. And then it's going to pull a vacuum on the evaporative emission system to a prescribed amount, whatever the manufacturer or whoever programmed the PCM from the factory, whatever figure they decided that should be. Then they're going to close the purge valve. So now the system should be totally sealed. Now what the PCM is going to do, it's going to monitor the fuel tank pressure sensor and see, is the vacuum bleeding off? Now it's normal to see some bleeding of the vacuum. I have never in my 28 years in the automotive industry seen a fuel tank pressure sensor or seen an EVAP system where the vacuum did not bleed off slowly. But again, you're looking for a slow bleed. If it bleeds off really quick, then you're probably going to have a large leak detected. If it bleeds off moderately fast, it'll probably set a slow leak detected code. And then it's just a matter of figuring out, where your leak is. The two main questions that the PCM is looking at here is, can I pull a vacuum on the EVAP system? And then once I pull a vacuum on it, is it able to hold a vacuum? And almost every EVAP code can be understood by answering just those two questions. We've looked at a wiring diagram. Okay, so my favorite evaporative emission systems test is not the smoke machine. In fact, as a tech, in 14 years of being a tech, and then the 14 years I was a service manager, I advised my techs not to jump right to the smoke machine. The smoke machine is a very handy tool, but it's not the first thing to go to. So the first thing I would always do is go to an EVAP Purge and Seal test. Now on GM, General Motors vehicles, on OBD systems, they call it Purge and Seal. Other manufacturers may call it something a little bit different, and I have seen on some manufacturers that don't have this capability. If that's the case, I'm sorry, but this is a fantastic test. So what I'm going to do here is I'm going to switch to a video of a scan tool actually doing the purge and seal test. And I did this on an Alero, a Oldsmobile Alero. So let's go ahead and jump to this video and start it up. There we go. All right, so I'm hitting EVAP Purge Seal here. And then it just gives you the explanation of what EVAP Purge and Seal does. Okay, so right now it's showing that the EVAP vent solenoid is venting, meaning the EVAP purge solenoid, the EVAP vent solenoid is venting to the atmosphere. But as soon as I hit the button up at the top, now you can see that it shows that it's not venting. And I have commanded the purge valve to open 10%. Now, what I want you to do is pay attention to the fuel tank pressure sensor, not necessarily the voltage, but look at the pressure on it, which is right up above the fuel tank pressure sensor. So right there, look at that and let's see what it does. All right, so you can see I'm pulling a negative vacuum, right? You can see the negative right there. Once it gets to around 9 or 10, yeah, I'll stop it. And then I'm going to see, does it bleed off? And you can see that it is bleeding off. Right now it's negative 1076, 1057, but it's bleeding slowly, right? That's what you want, is for a slow bleed. That means that the system is sealed, it's doing its job, it's able to hold a vacuum, and it's not bleeding off quickly. So in theory, this vehicle should not have a code set. I'm just going to look over here and clear there we go. I'm shutting the video off in case there's some background noise on it. So that's the video of the purge and seal test. Really quick, we just tested the purge solenoid, right? Because we were able to open the purge valve. It pulled the vacuum on the gas tank. And because it was able to pull a vacuum, we know that the vent valve also worked. Now, what I highly recommend doing is at the end of the test, if it's possible, to open the vent valve only and see how quickly the vacuum bleeds off, to know that the vent valve is working as well, because the vent valve could have been stuck closed, right? And so we were able to build vacuum up because of that. But that's a really quick test to let you know, are there any current leaks? In this case, there were not. Is the purge valve operating? Yes. Is the vent valve able to stay closed? Yes. So everything electrically is good. Everything mechanically is good. That is an operating system. So if it can pull a vacuum, great. Now, if it cannot hold a vacuum, this is where you might want to break out the smoke machine. First thing I'm going to do is check the gas cap. Make sure the gas cap is sealing. That's the easiest thing to check. Besides that, I'm going to jump into the scan tool and command the vent solenoid on and off. See if you can hear it clicking. You should hear an audible click coming from the rear of the vehicle when that vent solenoid is commanded on and off. If you don't hear a click, that could be a problem. If the vent solenoid is clicking, gas cap's good, you are definitely bleeding off pressure. Now's the time that I'm going to grab a smoke machine, hook it up, and see where the actual leak is, because the EVAP system's got a lot of pipes that could leak. But let's say that I had an issue with a code that says flow during non-purge, or when I hook up my scan tool and crank the vehicle up, I'm seeing a vacuum on the gas tank and it's steadily increasing. So what's that telling you? That's telling you your purge valve may be stuck open. And again, this is an easy thing to diagnose. Y'all, the purge valve is pretty easy to access, pull the pipe that goes to the fuel tank off of the purge valve itself. Put your finger over the port on the purge valve. If you feel a vacuum, that purge valve is pulling a vacuum. Okay, and that is your issue. If you're not feeling a vacuum, then you need to suspect the fuel tank pressure sensor. That could be a problem, especially after you pull the hose off. Because if your vent valve is stuck closed and you pull the hose off, then the fuel tank pressure should pretty much equalize close to zero. If it doesn't, then you've got a fuel tank pressure sensor issue. But if you're still feeling vacuum at the purge valve, unplug the purge valve, get a test light, and just jump between both the terminals on the purge valve. It's okay to do that. And it should be off if you've got it commanded off. If you don't have a light lit, then your purge valve is just stuck mechanically open. Replace it. If that light is flashing, being pulse width modulated, then you've got an issue. The PCM is turning on the purge valve when it shouldn't be, or it could be one of these situations where it's doing its self-test and you just happen to catch it during that self-test. If you have one that you have, the purge valve is working fine, fuel tank pressure sensor is working fine, but it just won't vent. One issue with vent valves is I have seen spiders build nests in the vent valve tubing. I have seen dirt daubers, little wasp-like things, build nests in there. Vehicles that are construction vehicles that work off the road in dusty environments. I've seen the filters for the vent valves get clogged up also, and that will cause it to either bleed the vacuum very, very slowly when the vent valve is open, slow enough to where the computer thinks there's an issue, or it won't bleed it at all. So that's another thing. And then again, the last thing is the fuel tank pressure sensor is just reading wrong. So this is my EVAP routine. Read the code description. Y'all, too many people, too many technicians and my own students do not read the code description. What does it take for this code to set? What does it take for this code to clear? Read that, because you will learn a ton of information off of reading the code description. Then go ahead and do that purge and seal test and see, can it pull a vacuum? Can it hold a vacuum? Then if it can't, test the purge valve first, test the vent valve next, and lastly, verify the fuel tank pressure sensor, because that's the hardest one to get to. And then the last resort is break out the smoke machine and do a smoke test. So if you follow this routine on a regular basis, you will be very successful doing evaporative emission diagnosis and repair. I promise you. Remember, the code, no matter what code you have, the code isn't telling you, hey, this part is bad. The code is telling you the system where there's a fault. And then it's up to you as the tech or the student to figure out where the issue is. I get so tired of hearing, hey, I've got this code thrown. I need to replace this part. Get that out of your brain. Let's understand how this works and diagnose it right the first time and get it fixed right the first time. So your job is figuring out why that test that the PCM was running failed. And it's not always a bad part. If this video helped you understand EVAP systems, if this series of videos helped, please leave a comment. Please like and subscribe to my channel. Every time I make a video, I try to break down systems to make them simple and easy to understand for you. To help you understand really how easy electrical and drivability issues really are. If you've had an EVAP system that has driven you absolutely nuts, drop it in comments. Let me know what it was and what you found wrong with it as well. I love the really odd, diagnosing and repairing stories. So please share a story in comments. Until next time, thank you so much for liking, subscribing, for the comments. I really appreciate it. Take care of yourselves and God bless.